So in this video we are going to study about decomposition reaction, and for that we need to perform an experiment. So in this experiment we need a few things. Try to see a plastic mug, then you need 2 test tubes, okay, with rubber stoppers, then you need a 6-volt battery, and you also need 2 graphite rods. Okay, so these are the things which are required for this experiment. We will have to set it up in a particular manner. Okay, so a pictorial representation of the same will be available in the next page. So let me try to show it to you. Okay, so now try to see what exactly happened. First of all, come to this line. Take 2 test tubes filled with water and invert them over the 2 carbon electrodes. So the test tubes you saw, you need to fill them up with water and then you need to invert it, okay, and connect it to the anode and the cathode. Okay, and then overall there will be a switch and connect the whole thing to the 6-volt battery which was mentioned to us. Okay, now this is the entire setup. It's all happening inside the plastic mug, and you can see we are having 2 different gases. Okay, we are talking about water. What is water made up of? Water is definitely made up of H plus O. Formula is H2O, but it's hydrogen and oxygen, right? So you see the 2 test tubes, actually one having oxygen, one having hydrogen, and then both having water. You can see the bubbles also, and there will be particular observations. Okay, now what are the observations and why are they happening? Let's try to actually understand the entire thing, the entire process. Okay, so firstly, why anode and cathode? The first concern here is the anode and the cathode. So let's try to understand. The volume of gas collected in the test tube at the negative electrode, that is cathode. Okay, so first of all you have to understand cathode is the negative electrode. So on this side cathode, let me do the sign negative. On the other side definitely the other one will be positive, so anode will be positive electrode. Okay, so positive electrode and negative electrode. Now will be twice that of the gas collected in the test tube at the positive electrode. If you can see the pictorial representation, in the cathode, that is the negative electrode, you can see there is more space and less water. Less water, more space left, more air basically. And in this case, in the anode, that is the positive electrode, you can see less space left, like less gas and more water. The quantity of water is more in case of anode and the quantity of gas is more in case of cathode. And why is this? Because one is negative, that is the cathode, and one is positive, that is the anode. And you can see clearly this distinction, and it's double. You can see it's actually double, it's seeming like double in the picture also. So this is the first observation in this experiment. Okay, now let's go to the next observation. Now we are particularly talking about cathode in this case. Okay, so what is the thing we are talking about? The gas in the cathode test tube, more volume, is hydrogen. As we discussed in the beginning that water, we are conducting this experiment with water, and water has its 2 components, hydrogen and oxygen. So in the cathode test tube we have hydrogen. So basically more of the gas is hydrogen, and you know it's a very simple thing. Hydrogen, 2 elements, H2O is the formula, and this H2 is actually coming in the cathode. Okay, that is the negative electrode. It burns with a pop sound when a burning candle is brought near. So that's another thing, another very interesting part of this experiment. When you actually bring a burning candle, so it burns with a pop sound. Okay, so these bubbles you can observe. So bubbles, they will be burning with a pop sound. Okay, there will be a popping sound, and that is the observation in case of the cathode. Similarly, there will be some observation in case of the anode too. Let's try to see. Oxygen on the other side. First of all, see, as we discussed, it's less quantity of the gas, more quantity of water, and the gas in the anode test tube, less volume, is oxygen, O2, as we discussed. It relights a glowing splint confirming the presence of oxygen. So it will actually glow on the other side. Like what did we discuss? In case of hydrogen, it will be burning with a pop sound, and in case of oxygen, it will be glowing with a splint. Okay, so that is the difference. In anode, because it's positive, we have the oxygen, and in case of the negative, that is the cathode, we have hydrogen. So this is basically the difference. Okay, you can see cathode test tube and anode test tube. Now, so here's a question for you. In the experiment we performed, the anode test tube contains, then we have a dash and gas. So which gas does it actually contain? First of all, we have hydrogen, then we have helium, and then we have oxygen. So as we discussed, that anode test tube is the positive test tube and it contains option 3, that is oxygen gas. We discussed this, okay. Now, we discussed so many things, what is actually happening, what are the observations, okay, the oxygen is actually glowing, hydrogen is burning with a pop sound, but what is the entire process which is happening? What do you name this process? The process demonstrated is electrolysis of water. Electrolysis of water, so in that case, this is the name of the process. So in case of electrolysis of water, what is exactly happening? Where water molecules are decomposed into their constituent elements, that is hydrogen and oxygen. As we discussed very simply, H2O, it's made up of H plus O. This is not the reaction, don't confuse this with the reaction we have written here, but I am trying to explain it in an easy manner. H2O is made up of hydrogen and oxygen. So this is very simple, the water molecules are breaking down into its constituent elements, and that process is known as electrolysis of water. It can be represented in this chemical reaction. So what is it? 2H2O, okay, that is L here in this bracket means liquid, of course, and you have 2H2, that is gas, plus O2, that is gas. So this is the equation you need to remember, okay. So again, electrolysis of water, where water is actually breaking down into its constituent elements, that is hydrogen and oxygen, and this is the chemical reaction for the same, okay. Now try to observe something different. So we are done with that experiment. Here we have silver chloride. So it's white in color, but you can see slowly it's changing its color. It's turning into grey, and now see it's more grey. Put some more silver chloride which is white. You can see slowly it will again also turn grey. Yes, it's turning grey. And you can see on this side it has become more grey. And this side it's turning, and yes, now the entire thing is grey. So you saw that it's continuously over a period of time it transformed from white to grey. You can see, okay, this is the entire process. So silver chloride, you can see it's transforming from white to grey, and what is the only thing you can observe in this entire process? You can see sunlight, right? Sunlight is falling on it. It's not happening behind closed doors, okay, inside a dark room. You can see this process is occurring when there is sunlight. So now let's try to understand our observations. Okay, so this is the silver chloride we were talking about. It's white in color and it transforms to grey color. Silver chloride is initially white in color, but when placed in sunlight, it undergoes a photochemical decomposition. So again, we talked about decomposition there, we are talking about decomposition here also. And decomposition is nothing but basically the main element, the primary thing we are talking about, in this case silver chloride, in the last example it was water. So it's breaking down into its constituent elements. So silver chloride, in the presence of sunlight, it happens to it, okay, right? You can see what exactly happens. The white silver chloride gradually turns greyish black. White changes to greyish black. So this is the entire process which happens in case of silver chloride. Now, okay, the decomposition of silver chloride can be represented by the following equation. So in this case also, let's try to see the equation. We can see 2AgCl, okay, that is silver chloride, and when sunlight is applied, you have 2Ag, that is solid, plus Cl2, that is gas. Okay, so okay, this was again solid, this is a solid, and this is a gas. Now this is the entire thing which happens for silver chloride, and basically silver, you know, it's Ag. The formulas you need to remember: 2AgCl, sunlight is applied, 2Ag plus Cl2. So this is what happens in case of silver chloride when it comes under the direct contact of sunlight. Now we will be summarizing the entire process of decomposition. Okay, we saw two examples. Okay, first of all, the experiment of water, and then the experiment of silver chloride. Silver chloride was not an experiment, it was more of an observation. Whatever. Decomposition reaction is a reaction in which a compound breaks into two or more substances. First thing, this is the first point. You saw in both the cases it's breaking down into two or more substances. Okay. Second point, requires energy in the form of heat, electricity or light. You saw in the first example we had electricity. There was a battery, there was cathode and anode. In the second example we had heat, like sunlight. You can say heat also, you can say sunlight also, because sunlight provides the heat, and light also. So there is some sort of energy. There is an element, additional element which is coming into play in this case. Okay, so that is the second point. And the final point is endothermic reaction is a chemical reaction in which the reactants absorb heat energy from the surroundings to form products. Exothermic is absolutely the opposite of this. You have already studied. Endothermic, there are certain reactants around the main element, the primary element we are talking about, and it absorbs the heat energy from the surroundings, and then the change occurs. Okay, like in this case the change is basically they are forming products or they are changing color, whatever it can be. But these are the 3 points you need to remember. First of all, the definition of decomposition reaction, two or more substances it is breaking down into. There is what is happening, but why is it happening? Because there is some form of energy involved, right? And then what exactly is happening in this case? How can you actually name it? It's endothermic reaction. How it is happening? It is actually the reactants absorbing heat energy from the surroundings. All the things we are talking about, heat, electricity or light, whatever is there, it's absorbing the heat, absorbing the energy from that, and then the change is occurring. Okay, change in the form of products, or you can say in the form of changing of color or any sort of change basically. So that is all about decomposition reaction. Now let's try to note down everything we studied in this video. First of all, we knew that we had to study what is decomposition reaction, and we saw two examples. Like one is an experiment in which we actually saw that how in cathode and anode test tubes we got two different gases which constitute water, a very primary element. So hydrogen and oxygen. Oxygen was in the positive test tube, that is the anode test tube, and hydrogen was in the negative test tube, that is the cathode test tube. We could see that hydrogen and oxygen, these are the primary elements which form water. So water broke down into these two primary elements when electricity was applied. Okay, in case of a third element, that is an energy, in this case water broke down into its two constituent elements, and this process was known as electrolysis of water. And through electrolysis of water, water decomposes into its constituent elements. So this was an experiment. Next we studied basically an example, you can say. It was not an experiment, that silver chloride, okay, which is white in color, when sunlight is applied, it changes its color. Okay, it changes its color to grayish black or grey, whatever you can say. So grayish black color, it takes a transformation. Again, in this case also there is an involvement of an energy, that is sunlight. And finally we studied that what are the three primary things about decomposition reaction. First of all, the definition of decomposition reaction, that by some energy it breaks down into two or more substances. Then also we talked about how it is happening, like it requires something, right? It requires heat, electricity or light. And finally, it's an endothermic reaction in which it's actually taking the heat, absorbing the heat energy from the surrounding elements and then forming the products. So these are the takeaways from this video.